Welcome to the Out of Bounds Read podcast, where we help inform and grow the community around common weakness enumeration and common attack pattern enumeration and classification. This podcast is produced by the MITRE Corporation with funding from the Cybersecurity and Infrastructure Security Agency.
Hi, I'm Steve Batista. I'm here with the CWE podcast, and I have two guests, Tim Wadhwa-Brown and Jared Pendleton. Tim, could you introduce yourself, please?
Yeah, hi. I'm Tim. Glad to be talking. I'm from Cisco, and I look after security research and, I suppose, offensive security for professional services here in Europe.
And Jared.
Jared Pendleton. I'm in Cisco's Advanced Security Initiatives group, and that group, I guess, looks at internal product security for Cisco.
Excellent. I've been told that Cisco's a real power user of CWE. What do you find useful about CWE in your roles?
I'll let Jared go first, and then I'll give my answer.
Okay, well, so as you know, security is really all about finding and fixing vulnerabilities. And when you're looking for vulnerabilities, you don't really need to classify them. You don't really need to classify them as various weaknesses. But then the more mature your security program gets, the more you need to start being proactive about the sorts of security vulnerabilities that you find. And so when we can then classify these vulnerabilities in different weakness types, then at that point we start to see trends about where our engineers are making more mistakes, or what particular technology, operating system, platform is susceptible to various other kinds of mistakes. Then we can also reason about whether or not it makes sense to invest in tooling, either building our own scripts or static analysis or whatever, or buying something off the shelf that'll help find vulnerabilities. To be able to name them, to be able to pile them or bin them up into different categories really is helpful for that.
So from an external perspective, professional services is expected to be able to contextualize the issues that we find. And so for me, the entire MITRE framework, not just CWE, comes in really handy for that. If you look at vulnerabilities in isolation, you sometimes miss the big picture. And so particularly when you're looking at operational systems, being able to cluster groups of vulnerabilities and say, well, actually, this is representative of a more systemic problem. It's not merely the case that you've forgotten to validate your input here, but actually perhaps you've forgotten to consider validation as a concept in totality. You haven't specified the inputs and outputs, the APIs, etc. So it's that contextualization. Where did the customer go wrong? Did the customer go wrong with one line of code, or did they go wrong with the strategy that they handed across to developers?
Yeah, from someone in my shoes that have been doing this as in security since the early 90s, my mindset in the beginning was that all security vulnerabilities revolved around some kind of buffer overflow or buffer overwrite. Are you finding that to be the majority of your errors or weaknesses, or are you finding other weaknesses that are important?
It's interesting. So we started using CWE years ago. So we have a fairly structured, robust mechanism for reporting. It's database driven, and we started labeling the issues we were reporting to customers about 10 years ago, as I say. In the start, we were kind of picking our way through CWE, and we weren't always finding what we were looking for. We started off with about 20% of vulnerabilities we could kind of cluster into CWE categories. We're up to about 80% now, and that's pretty much consistent year on year. Of those, quite a large chunk are traditional software development issues, but also because we're seeing other vendors' products. We're seeing people's processes. We actually see about 20% of issues that actually we think they don't really tie into a software development mistake. They rather tie into potentially a process mistake or a documentation mistake or even perhaps a procurement mistake. We bought the wrong product and we didn't have the team that could support it.
And Jared, for you, how are you finding that mix when you start binning things?
Like Tim said, there are a lot of vulnerabilities that we can't really classify under CWE because they're operational in nature and they're not really software development. So we're kind of as an aside, we're exploring the possibility of using the attack framework to, I guess, classify those operational weaknesses in the same way that we do with CWE. As far as the sorts of weaknesses that are common that we find a lot, Cisco has a lot of legacy code. iOS is 25 years old, something like that. It's ancient, and an embedded program, and there are every year more and more buffer overflows, things that the typical weaknesses that you would get out of C. That said, we also have we don't just have legacy. So when we've got an application, written in Java, or Go is popular now among developers, and when you switch to a language or a framework that doesn't let you shoot yourself in the foot when you're doing buffer management, then the types of vulnerabilities, the types of weaknesses that we see differ, and it's I guess it's higher up in the stack, as in, instead of buffer management and then getting some arithmetic wrong or adding buffers incorrectly or what, it's like information exposure, where application level data and application level critical configuration, etc., that becomes a much bigger part of the weaknesses that we see in those platforms and frameworks.
Are they veering more towards flaws than bugs then, or you're getting an equal mix of those?
So I can't
flaws being designed and bugs being implemented.
Yeah. So from a professional services perspective, the two biggest hitters on our reports are information exposure, which can happen in any language. We did some research just that came out, I think, about a month ago with some Cisco products where we found some information disclosure type vulnerabilities, and then cipher suites. And you can imagine every service on the network now is TLS wrapped. So when you find one, you find many, and actually that points to a more characteristic weakness that the organization hasn't really set the approach to TLS. A set of ciphers that is agreed upon and can be configured and baked into all of the products as one distinct way of doing things versus every product being left to fend for itself. Just to pick up on a point Jared made about attack, I think I absolutely agree. Attack's kind of useful for that operational piece. We're actually looking at how you map between CWE and attack, because there's a distinct overplay. I mean, you think about exploit publicly facing web application, which is inside attack. Well, that pretty much encompasses most of CWE in some fashion. And if you think about some of the pivots around the network, again, you'll probably find that those pivots happen because of weaknesses that may have been introduced because software development lifecycle, either within the organization or within the organization's vendors, wasn't quite right. So the two interlock nicely.
One of the things you can look at is if the attack framework doesn't cover the specific operational need, there's the CAPEC framework, which is a little bit more expansive. It's not focused on APT and common attacks, but more of a taxonomy, but it's a lot more, right? So I think one of the good things about attack is it's very concise on the popular things, but it's not exhaustive. and it all depends on which side you need to lay down on.
Yeah, no,
Yeah.
I'd agree. It's interesting we pivoted into talking about attack on the CWE podcast. I think, understand that's the critical piece for me when I talk to customers, is understanding the relationship between all of the different taxonomies that MITRE represents. Yeah, from CVSS, which is down to the individual vulnerability, CVE, which is the product, the version, right through to kind of attack and KPETR at the other end. They all interlock, and that from a professional services standpoint, that's why I focus on using MITRE's frameworks, is because I can actually pivot from one to the other and give a view of an organization or a view of a system that's consistent with the capabilities and knowledge space of the person I'm talking to. If I'm talking SOC, I'm probably going to talk towards the attack end of the spectrum. If I'm talking to the guy that's written the Go code or the Python code, I'm almost certainly going to be talking down in kind of CWE, CVE, potentially even CVSS. Know how the taxonomies work together, I think, is a message that I would reiterate.
That's really good, and there is a new one out, I believe, called Defend, that the NSA is sponsored out of MITRE, which is the defensive side of attack, I believe, like what you should do with the attack. So, for me, when CVE came out, I really thought that was a godsend, because before there were numbers, one, none of the IDSs lined up. And two, when I had to explain something to someone, I had to explain it in a paragraph.
Yeah.
And it, like that thing over there that looked like this with the computer in the computer, blah, blah. Now I've got this like handle that I can say, oh, I want to talk about CVE 2022 XYZ. So just even having the names helps in those things. When you're looking at these weaknesses, are they more implementation bugs or design flaws?
For us, we see a mix. A lot of them are bugs, and then also to Tim's point about TLS, sometimes when we find a bug, when we find a vulnerability, we 10 more of them just fall out, and then at that point we see that it's a systemic issue in this particular platform, or so. At that point, when we have that common language and that classification to say, hey, you know what, there are crypto problems in this platform all over the place, and then we talk to engineering leadership for that particular team and say, hey, you guys should really invest in some more training on TLS for your entire team, or something like that.
Is it that the list of allowable crypto isn't reduced? They just let any type of crypto, or what did you find in there?
Well, I mean, there is a lot of that, yes, where an insecure protocol is allowed, but really it runs the gamut. We've got a lot of different products. We see everything.
Yeah, one of the things I was surprised when I looked into the Polkit vulnerability was that it used this common way of enumerating through the arguments of a function that I was taught when I wrote C a billion years ago, and that everybody uses, and that turns out to be wrong, because if for some reason there's no arguments to include, there's no function, no thing you called in the beginning, it causes an off by one error and this memory issue. And what surprises me is that externally people say, well, look at these bugs, don't they know any better? And you go, well, but that's what everyone did for 30 years. And now you're telling me that 30 years of history is wrong. And so then,
yeah,
it's interesting.
That's one exciting thing working in security, in that regardless of the platform and the technology, it's all built on the same fundamentals. And you have to be pretty versed in those fundamentals to be able to figure out. You have to know the rules before you can try to break them. And then even then, when you're trying to figure out how somebody else broke them or could break them, That gets more interesting sometimes.
What's old is new. And I guess to take that point a stage further, one of the reasons that we do a lot of the work on kind of collapsing our vulnerability tree into reports is because just because it was a coding weakness in sudo or a coding run in whatever low level piece of code it is, by the time it gets into the hands of the people who are operating the platform, it's not. So if we were to sit there and just simply say, well, there's all these issues and they're all individual coding issues, we're doing, the operational team, the engineering team inside a bank, or the operational team or the engineering team inside a service provider no favors, because they can't address that. What they potentially can look at is, well, actually, did we have a more systemic problem, which is where we cluster around, for example, our patch management process, or around the way we provision user access to the system. Do we actually have a process that means that all of those default passwords that you see in almost every vendor, Cisco by no exception, that there is a process for the organization to take those passwords, cycle them as they bring them into the environment? Because if they don't, then whilst you can kind of say, well, a vendor has a responsibility because they introduced the problem in the first place, at some stage, right, you sell a car, it's no longer your responsibility if someone crashes into somebody. There is a degree of liability shift that happens when you procure or use a product, and guiding people on how to use the products safely. That's professional services mission, not merely to make sure that the code is correct.
And I will add on to that. As we all know, it's obvious. When you're talking to an engineer, you're going to have a different message than when you're talking to middle management, and that's even going to be a different message than when you're talking to executive leadership or business or whatever. All of these different people consume information differently, and so one thing we do with CWE is I guess change the level of summarization, as in. As you know, CWE is vaguely a tree: variant, base, pillar, class, and then just sometimes you could get categories in the mix. But when we're talking to very technical folks, we try to keep summarization at either the base level. So if we find it and tag a variant, then report everything as base and summarize that. And then we also do, we call it class low and class high, because there are multiple levels of classes typically. And so at some given point, we'll summarize at the lowest level class in the tree, and at the highest class in the tree. And those different messages, those different summarizations, the higher up you get, the more generalized they are, and they're more appropriate for executive leadership, the technical executive leadership. Whereas when you're in a foxhole, when you're talking, nuts and bolts with engineers, then at that point, a much more detailed level of summarization is appropriate, we find.
And when you talk to those executives or the middle management types, does the summarization really help? I mean, that do you say like, hey, a certain percentage of your weaknesses that lead to vulnerabilities are in this area, and you need to have your teams focus on this?
Sometimes it does, and sometimes it doesn't. It really all depends on the distribution, and that's another reason why we might want to change our summarization, because it could just be that they're making lots and lots of varied mistakes, and you don't see a particular single kind of mistake, and it's just low quality code, or sometimes the opposite. You're not seeing much at all, and it's high quality code, and that if you use CWE to tease out classifications, and you see one of or two or five of these classifications are far and away much more prevalent than others, then at that point, you need to focus on those, 1 to 2 areas.
So we tend to cluster about 5 CWEs per attack surface, and each of those 5 CWEs per attack surface then will map into approximately 5 tactical areas of improvement for the organisation and 5 strategic areas of improvement for the organisation. And the tactical ones will be, all of the credential management stuff will actually go away and check all your passwords that we've reported as being weak, check that they're sensible. And then the strategic one might be actually you need to have a mechanism for managing your passwords. You need to have a password locker. You need to have a break glass mechanism. And back to Jared's point, very different audiences. The executive who's going to sponsor the break glass identity access management solution is probably going to have the budget to do it. The person that's responsible for that particular project at kind of an architectural level, that's really not going to be something they can do. So you've got to give both parts of the organisation the ability to improve, because if you rely on one part in isolation, well, we know fixing one thing in one place is never enough. Yes, security in depth is a fairly strong mantra. So we help customers fix it everywhere if we can.
Is there one set of weaknesses or things that come up quite a bit that if you had a magic wand and could say, overall they would go away, it would make your job feel better? Because I know, in doing some of this work, sometimes you're like, oh no, it's not that again. Is there something that comes up a lot that it's like, oh no, it's not that again?
TLS, because from a professional services engagement, the number of reports that end up with TLS, 4, 5, 6, 7, a dozen different issues for different variants of the underlying problem. And I guess, Jared, you might want to speak about the PSBs and how we use them, because that's certainly part of something that I would expect mature organizations to have, and we don't often see it, the idea of a common standard for crypto.
Yeah. Well, I guess to answer Steve's question from my thing, it's input validation. That's whether it's OS command injection or XSS, anything. It's input validation is the bane of my existence sometimes. But Tim brings up the PSB. So at Cisco, we've got Cisco Secure Development Lifecycle, CSDL. And that is, a set of processes that are enable us to, securely build our products. And the PSB, Product Security Baseline, is a set of requirements that go into CSDL. And they don't all map to CWE. And some of them map, but not one-to-one. But it's when Cisco finds, common weaknesses, common mistakes, common anti-patterns, over and over in our products. Then at that point, we look into how do we augment the rules and requirements? How do we augment the PSB? And CWE does help with that, even though it's not a one-to-one mapping from PSB to CWE. It's difficult to lay a requirement around a CWE. So that's why it's a little bit different. The audience for CWE versus PSB, but they do align. And yeah, is that what you were looking for, Tim?
Yeah, I was kind of just thinking that lots of different cryptographic weaknesses in isolation, and it's the CWE tree that allows you to go, well, actually there's a common parent, which is you don't understand your cryptographic requirements, and things like the PSB are our opportunity to take a step in and say, well, actually there's half a dozen different things that come from the same fundamental place. Let's put a set of requirements in that captures and attempts to deal with them holistically.
So, what I took away from that is, have a series of security requirements before you build things, so you kind of know what you're building them towards, rather than just organically coming up and saying, oh yeah, well, I built this insecure car. Let's decide to move money in it all of a sudden, and then you're, You don't have bulletproof windows or anything like that.
Yeah, it's a baseline. Yeah.
I'm writing an SDLC at the moment for a customer, and that SDLC is being driven by CWE and mapping out the common weaknesses that affect the development platforms they've chosen to use. To go back to why CWE is really awesome is that I can go there and I can say, well, actually, which CWEs affect Python, which affect Java, and which affect C. And then I can look at how they map together, and using this whole concept of being able to condense and homogenize to some degree, I can say, well, actually, here's the point of entry. I'm almost building a PSB for the customer in a sense, but aligned specifically to the languages that they use.
Yeah, I do agree. When I look at like large C++ code bases, usually after free shows up all the time. So, depending on what your materials you build with, you have different weaknesses and, different tolerances. I really kind of harken back to 100 years ago when they built factories and they didn't know how to build them yet. And, they would blow up, or, they would leak, hazardous material, because we just, as a human race, didn't know how to do it yet. And we're kind of at that stage in software, we're kind of learning how to build these systems.
Yeah.
This has really been, go ahead.
We call ourselves engineers, but we're perhaps not quite there yet if you compare us with people who build bridges.
Yes, definitely. I totally agree. I always say I feel like I'm some country doctor where it's like everything is myth. Oh, yeah, well, we need to do that. Why? I don't know. It kind of works. When I look at the code I wrote 30 years ago, I'm embarrassed, which I guess is a good sign that things are improving. Yeah. So this has really been a great conversation. Is there anything else either one of you want to add to this conversation that I may have missed?
No, I think thank you for all the work that MITRE does. I think the last 10 years, it's been super helpful in helping us frame our discussions, whether that's at the developer end or at the offensive operational end of the spectrum.
Yeah, and I'll mirror something that you said, Steve, earlier, which is having that common framework is the most useful thing about everything MITRE does, because you can align words and convey ideas a whole lot more efficiently with other people than you can when you don't have that common framework.
Excellent. Well, thank you. It's been a great conversation, and it's been really great talking with you. I'm glad that you've been using the taxonomies to help talk about things. This has been great. Thanks.
Hey, you too. Thanks a lot.
Thank you.
Thank you for listening to the Out of Bounds Read podcast, available on most podcast platforms and at cwe.mitre.org. Stay up to date and connect with us on Twitter at CWE CAPEC. Until next time, take care.